Hi, this video is about solving for distance in Coulomb's law. So we've got two metal spheres here, and they are given charges of 33 microcoulombs and negative 55 microcoulombs. How far apart are they if they experience an attraction force of 5.33 newtons? So I'm going to start by listing things that I know. I've got the K constant here. I've got 5.33 newtons for my force. I know my charges here are 33 microcoulombs. I'm going to rewrite that as 33 times 10 to the negative 6 coulombs, because this 10 to the negative 6 is what micro signifies. And then I'm going to write this one as negative 55 times 10 to the negative 6 coulombs. And then the distance is our unknown value that we're looking for here. So I'm going to use the super secret math trick that I often use when I'm dealing with problems where the denominator is what I want to find. And the super secret math trick is you can swap the denominator for the value on the other side of the equation here. So I'm going to do that. I'm going to swap these two. And I can do this algebraically. I can show this algebraically too if I just multiply both sides by d squared and then divide both sides by the force. But that gives me a shortcut here. And even though shortcuts do make long delays often, this is a shortcut that is tried and true, and it's not a shortcut in as much as it's just a quicker way to do the algebra. So it's not a bad shortcut, I should say. There are other shortcuts where you're trying to shortcut the necessary work that you need to do in order to think correctly. So this is the super secret math trick that I've done now. Now I can solve for my distance. So I'm going to substitute in my values here. 8.99 times 10 to the 9 newtons times meter squared over coulomb squared. And then I have my fraction here. I've got 33 times 10 to the negative 6 coulombs, and I've got negative 55 times 10 to the negative 6 coulombs. And I realize now I should have done this earlier, but my force here is going to be 5.33 newtons. However, when I'm dealing with Coulomb's law and I have positive and negative charges, if we have positive and negative multiplied together, that's going to give me a negative force value, and it's an attractive force. So I should have realized up here that if it's an attractive force, that means that this should be a negative sign right here. Now we would have figured this out later when we're trying to take the square root of a negative number. It doesn't work. So you need this force to be negative in order for the negative sign to basically go away as we're solving for the distance here. So now that I've done that, I can multiply. I'm going to multiply K times Q1 and Q2 all in one step here, just to go a little bit quicker. So that's going to be negative 1.63 times 10 to the 1. And then the coulombs squared cancel out with the coulombs here. So that leaves me with newtons times meters squared. And then I'm going to divide that by negative 5.33 newtons. Okay, so as I divide, I'm going to cancel out the newtons there. And so that leaves me with distance squared equals 3.06 meters squared. And I still need to do the square root of both sides here. So as I do the square root, looks like I forgot to do that one over here. All right, so as I do that square root real quick, that's going to give me a distance of 1.75 meters. So that's all I've got for you in this video. Remember, shortcuts make long delays.